Hi students, today what is our sixth topic? Rational and irrational numbers. Already you know what is a rational number. Ratio of integers and denominator should not be equal to 0. A rational number is in the form of p by q and q is not equal to 0. P, q are integers. All these numbers are rational numbers. They are in the form of p by q, means you will have a doubt. Sir, 0, 1, 2, 3, they are not in the form of p by q, as they are in the form of p by q. 0 can be written as 0 by 1, 1 by 1, 2 by 1, 3 by 1. Already you have 2 by 3, means they are in the form of p by q, and q is not equal to 0. Denominator should not be equal to 0. If 1 by 0, it cannot be defined. That's why you can write 0 by 1 is a rational number, but 1 by 0 is not rational number because denominator is 0. These are all rational numbers. Next, what are irrational numbers? You already know. In introduction, I have already told you what are rational and irrational numbers. Rational numbers: root 2, root 3, root 5, root 6, root 7, all these, and pi or pi, e, and all these are irrational numbers. You have a doubt, sir, pi is equal to 22 by 7. It is not a rational number, it is an irrational number. It is approximately equal to 3.14, means pi is approximately equal to 22 by 7. That's why root 2, root 3, root 5, root 6, root 7, or pi, e, all these numbers are irrational numbers. Now, see root 4. Root 4 is not an irrational number. Root 1, root 4, root 9, these are rational numbers. Say root 4 is equal to plus or minus 2. What is the meaning of root 4? See, root 4 means 4 to the power of 1 by 2. It can be written as 2 square whole to the power of 1 by 2, and also it can be written as minus 2 square whole to the power of 1 by 2. 2 to cancel, you will get plus 2, and minus this 2 cancel, you will get minus 2. That's why the value of root 4 is plus or minus 2. Root 4 can be written as 2 and minus 2. What is the value of root 4? 2 and 1. What is the value of root 4? 2 and minus 2. It can be written as 2 by 1 and minus 2 by 1. That's why root 1, it is a rational number. Root 2, irrational. Root 3, irrational. Root 5, irrational. Root 4, rational. Root 6, irrational. Root 7, irrational. Root 8, irrational. Root 9 can be written as 3, and the value of root 9 is 3 and minus 3. Written as 3 by 1 and minus 3 by 1. Minus 3 by 1. That's why the value of root 9 is a rational. It is a rational number. It is also rational. Both are rational. These are rational numbers. You have terminating and non-terminating decimal expansion in this rational numbers. You see, I will take some examples. 1 by 2, 1 by 3, 1 by 4, 1 by 5. See what are terminating and what are non-terminating decimal expansion. 1 by 2. How can you write 1 by 2? It can be written as 0.5. If you divide 1 with 2, you will get 0.5. Or you can do like this. 1 by 2 is there. You divide it with 5 and multiply. 5 ones are 5. 5 twos are 10. See, 5 by 10 means it can be written as 0.5. 1 by 2 directly you can write 0.5, because if you divide 1 with 2, you divide 1 with 2, 1 with 2 point, you will get 10. 2 5s are 10. Therefore, 1 by 2 can be written as 0.5. Now, you take 1 by 3. You divide 1 with 3. 1 with 3. It doesn't go. Put 0. 3 3s are 9. You will get 1. Again, you can take 0. 3 3s are 9. Again 1. It can be written as 0, 9, 1. It goes like this. Means 1 by 3 can be written as 1 by 3 is equal to 0.333 like this, and also it can be written as 0.3 bar 3. 0.3. Now I will take 1 by 4. 4 can be written as 2 square. You multiply and divide with 5 square by 5 square. You divide and multiply with 5 square. 5 square means 25 by 2 square and 5 square means 2 5s are 10. 10 square means 25 by 100. 25 by 100 means you will get 0.25. When you divide 1 with 4, also you will get 0.25. I will take 1 by 5. You divide 1 with 5, you will get 0.2. And I am multiplying this with 2 and dividing with 2. 2 into 1, 2 by 5 2s are 10. It can be written as 0.2. When you divide 1 with 5, 0, it doesn't go. Put 5. 5 2s are 10. You are getting 0 as remainder. Anyway, you are getting 1 by 5 is equal to 0.2. See, this 1 by 2, it is terminating. You are getting remainder as 0. That's why it is called terminating decimal expansion. See, 1 by 3, you are not getting 0 as the remainder because 3 is repeating here. That's why it is called non-terminating repeating decimal expansion. 1 by 4. 1 by 4 can be written as 0.25. You see, if you divide 1 with 4, you are getting remainder as 0. That's why it is terminating decimal expansion. And also when you divide 1 with 5, you are getting remainder as 0. That's why it is called terminating decimal expansion. This is terminating. This is non-terminating decimal expansion. This is terminating. This is also terminating. In terminating decimal expansion, denominator is in the form of 2 to the power of n into 5 to the power of m. N are non-negative integers. In all these cases, denominator is in the form of 2 to the power of n into 5 to the power of m. You observe 2 to the power of n into 5 to the power of m. Mn are non-negative integers. You observe in this also 2 to the power of m into 5 to the power of m. In all these cases, in terminating decimal expansion, denominator is in the form of 2 to the power of n into 5 to the power of m. Mn are non-negative integers. If you observe 1 by 3 or 1 by 6, these are non-terminating repeating decimal expansion or recurring. Now I will take more examples which are terminating and non-terminating decimal expansions. A rational number p by q. P and q must be co-primes and the denominator q is in the form of 2 to the power of n into 5 to the power of n, where mn are non-negative integers, is called terminating decimal expansion. Now I will take some more examples. Already I told you 1 by 2 or 1 by 2 is a terminating decimal expansion because 1 by 2 can be written as 0.5. 1 by 4 can be written as 1 means 0.25. That's why 1 by 4 it's a terminating decimal expansion. 1 by 5 it can be written as 0.2. These are all terminating decimal expansions. Now we will take some more examples. We will check whether they are terminating or non-terminating repeating decimal expansions. 3 by 8. 3 by 8 can be written as 3 by 2 cube, and I am multiplying this with 5 cube, multiplying dividing with 5 cube, and also this can be written as 3 into 5 cube means 5 5s are 25, 25 5s are 125 by 2 into 5, 10 to the power of 3. This can be written as into 125, 375. 10 cube means 1, 2, 3, 1000. This can be written as 1, 2, 3. That's why this can be written as 0.375. What is the value of 3 by 8? 3 by 8, I wrote the denominator in the form of 2 to the power of n into 5 to the power of m. We got 0.375. This is terminating decimal expansion. We will check whether this is terminating or non-terminating. You see 13 by 125 means it can be written as 5 cube. I am multiplying this with multiplying and dividing with 2 cube. Here 2 is there. I multiplied and divided with 5 cube. Here 5 cube is there. I am multiplying and dividing with 2 cube. This can be written as 13 into 8. 5 means 10 to the power of 3. 104 by 10 cube means 1000. 1, 2, 3, 3 0. 0.104. 0.104. This is terminating decimal expansion. We will check whether 4 by 21 is terminating or non-terminating. It can be written as 4 by, this can be written as 7 into 3. 7 3 is a 21. It cannot be written in the form of 2 to the power of n into 5 to the power of m. That's why it is non-terminating repeating decimal expansion or recurring. Now we will do some more terminating and non-terminating decimal expansions. Check whether the following terminating, non-terminating decimal expansion. 7 by 200, 1 by 6, 29 by 120. A terminating decimal means denominator must be in the form of 2 to the power of n into 8 to the power of n, mn or non-negative integers. We will take 7 by 200. 7 by 200 I will take. First we have to, these are co-primes, they must be co-primes. Have to do prime factorization. 200 you take, 200 can be written as 2 into 100 and also 2 into 50, 2 25s and 5 5s. As this can be written as 7 by 200 can be written as 2 cube into 5 square. Denominator is in the form of 2 to the power of n and 5 to the power of m. N, m are non-negative integers. Again we will do what is the value of 7 by 200. You multiply and divide with 5. This can be 7 5s are 35 by 2 cube into 5 cube. There is no difference in the value of 7 by 200. See, 35 by 2 cube into 5 cube. 2 5s are 10. 10 cube. It can be written as 10 cube. Now 35 by 1000 is equal to 123 0.035. As if you divide 7 with 200, you are getting 0 as the remainder, and this is terminating decimal expansion. I will take this one 1 by 6. 1 by 6, it can be written as 3 into 2. Denominator cannot be written in the form of 2 to the power of n into 5 to the power of m, because 3 is there here. That's why it is non-terminating repeating decimal expansion. You divide 1 with 6. See, 6 0 point. You will get 6 1s are 6, 40. 6 6s are 36. Again 4. 6 6s are 36. Like this it is going. 1 by 6 is equal to 0.16. It is non-terminating repeating decimal expansion. Now I will take 29 by 120. 120 can be written as 2 60s, 2 30s, 2 15s, 3 5s. This 120, after prime factorization, 120 can be written as 2 cube into 3 into 5. As 5 is there, even though 5 and 2 is there, but there is 3 in the denominator. That's why denominator is not in the form of 2 to the power of n into 5 to the power of n. That's why it is not terminating decimal expansion. Therefore, this is non-terminating. That's why 29 by 120 and 1 by 6 are non-terminating repeating decimal expansion, because denominator cannot be written in the form of 2 to the power of n into 5 to the power of n, where mn are non-negative integers. I think you have understood what is terminating and non-terminating repeating decimal expansions. Hi students, already you know real numbers are divided into rational numbers and irrational numbers. Rational numbers are denoted by q and irrational numbers are denoted by q dash. What are irrational numbers? Root 2, root 3, root 5, root 6, 2 root 3, 5 plus root 3, pi constant and e constant. All these are irrational numbers. What is the value of pi? Pi is approximately equal to 22 by 7. What is the value of pi? 3.141592. It goes like this. And what is the value of e? It is a constant, 2.71828. These are all irrational numbers. And what are rational numbers? You know, rational numbers are, these are integers, positive integers, 0, -1, -2, negative integers. And also we have rational numbers are in the form of p by q. Anyway, 0 by 1, 1 by 1, 2 by 1, 3 by, all these numbers, -1 by 1, -2 by 1, all these numbers are in the form of p by q. These are integers and these are fractions. These fractions we know, already we know, they are terminating and non-terminating repeating decimals. We have to identify which are terminating and which are non-terminating. See 1 by 2. Already I told you 1 by 2 is terminating decimal expansion. 1 by 2 can be written as 0.5. If you divide 1 with 2, you are getting remainder as 0. 1 by 10 also terminating. If you divide 1 with 10, you are getting remainder as 0. These two are terminating. Now I will take 1 by 15. You observe 1 by 15. 1 by 3 into 5. You see 5 is there, but 2 is not there. Even though 5 is there, 1 by 5 is a terminating decimal. But here you are having 3. And anyway, we will divide 1 with 15. You are getting 0.0666. It is repeating. Therefore, this is non-terminating repeating decimal expansion. Next, here in 15, 3 is there. In 2, 3 is not there, 7 is not there. In 10, 2 is there, 5 is there. Okay. If 2 and 5, either 2 or 5, or 2 and 5 are there, it is a terminating decimal expansion. Now you observe 2 by 7. You divide 2 with 7. What are you getting? If you divide 2 with 7, you are getting, see, 0.285714. Again you are getting, repeating, 285714. It is a repeating one. 285714 is repeating. When you divide 2 with 7, that's why 2 by 7 is non-terminating repeating decimal expansion. You see 100 by 81 also non-terminating repeating decimal expansion. Why? You see 100 by 81. After prime factorization 81, 327, 3 into 27, 81. 3 9s are 27. 3 3s are. It can be written as 100 by 3 to the power of 4. Here you don't have either 2 or 5 or 2 into 5. You have 3. That's why it is non-terminating repeating decimal expansion. See 1 by 15, 2 by 7, 100 by 81. These are all non-terminating repeating decimal expansions. Now, see, I will tell you one technique. How to identify terminating and non-terminating. I will tell you one technique. If 2 is not there, either 2 or 5 is not there, 2 and 5 are not there, then it is non-terminating repeating decimal expansion. You observe in 15 you have 3. You see 2 by 7. In 2 by 7 you have in the denominator 7. In 81, in the denominator of 100 by 81, you have 3 to the power of 4. You have 3. That's why it is non-terminating repeating decimal expansion. That is the technique. If you have 3, 7, 9, 11, 13, if these numbers present, then they are not terminating decimal expansion, but they are non-terminating. I think you have understood what is terminating and non-terminating.